right, hello, everybody. How's everybody doing today? Good to see everybody here today. I hope you're all doing absolutely fantastic. Hopefully, everybody had a good weekend. Here for another rip-roaring session of Math 102. Have I booked where I'm staying? Not yet. I don't know where I'm staying right now. I have no idea. I mean, I want to visit, I want to visit London proper, just kind of roaming around. I know 3 weeks is a long time, but I like to do a lot of roaming around. So, um, I just like to walk around and find hidden gems and everything like that. All the tourist stuff is fine, but the hidden gems are what I'm after. Good evening, Hisa. Good evening. How are you? How was your weekend, Hisa? Yeah. When am I going? Oh, yeah. So I booked a plane ticket to London. I'm gonna go right after the semester's over. So on that 17th, I am jet setting out right away. I got a lot of work to do before I even get there, but I'm jet setting out the 17th. I'm landing the 18th. Yeah, my weekend's pretty good. My weekend is pretty good. Cross our fingers. Hopefully, cross our fingers. I can go because COVID and all, but it's always a specter of something. But cross my fingers, I'll be able to go, and we shouldn't have too much of a problem. Is it expensive to vacation out there? Great question. I wish I knew, Julian. I don't expect it to be if I rationalize well enough. Hey, Aiken, how we doing, my friend? I think it'll be fine. You know, I mean, yeah, pounds. I mean, pounds are the most expensive currency in the world. That's true, but you don't have to spend like a ton of money every single day. Like, most of my money will probably go toward the plane ticket and the, you know, probably Airbnb or whatever I decide to end up with. When are we getting sub badges done? That's a great question. I have no idea. I don't know. When should sub badges be done? You want to do them for me, I can go ahead. I have no idea what to do with this channel about half the time. So, I need ideas. Um, uh, we could go with Oh, I know, Aiken. We could go with brown or bronze, silver, and gold drapes. That's exactly what we could do. All those drapes, man. You gotta love your drapes. You gotta be bronze, silver, and gold drapes. Just like the ones you have hanging in your background, my dude. They look exactly the same. uh... Nice big curtains, bronze, silver, and gold. Oh my goodness. Okay, yeah, I let Aiken know. If Aiken can swing me a ticket to a football match, that'd be stellar. That'd be absolutely fantastic. I'd love to go to a football match and just take one in. If it happens to be the Leicester Everton match or a Brentford match, I definitely would love to go. If I can go, though. And I know they're very popular, so. Can you make money off of here? You mean like It'd just be me screaming it. But that's fine. I don't mind that. Can you make money off of here? You mean like making money off of Twitch, Julian? I mean, you can make money off of here. You get if somebody subscribes to your channel, you get to keep 50% of that sub, so that's $5. So you get to keep $2.50. Then you can also donate money as well through PayPal or whatever, credit card or something. There's donation stuff. It's all part of the description in the channel. Now I don't promote doing subs on the channel or nothing, because for the most part we're here to do class and learn. So it'd be disingenuous of me. It'd be disingenuous of me, to be fair, Julian, to ask anyone to sub when they've already, number one, paid for the course, and number two, donations would just be a kind of an extension off of that, and that too would be disingenuous. So I say, if you want to volunteer, I will say, yeah, you can volunteer to do that, at your own request. But I would not say that you have to, because that wouldn't be very right for me to do. I sub because I don't pay for any courses. How many times have you been to the Bears games? I've been to how many Bears games I've been to now? 2. Yeah, just two Bears games. 2 Bears games. Tickets aren't cheap at Bears games, but you can get them on the resale market. They're a little bit more accessible for American football than maybe English football, probably because of the number of supporters and the number of hoops that you may have to jump through. Weather today, weather is really nice today. I won't lie. Weather is super great. It is like perfect weather outside. Today is 21, a perfect 21 degrees Celsius. Good afternoon, Angie. How we doing? Oh, no, you're fine. We haven't started just yet here. We're about to get started in just a second. All right. Well, speaking of that, I probably should start. Maybe that's something I should do. Maybe I should do the job that I'm supposed to do. 21 degrees Celsius, so it'll be 70. It's 70 degrees Fahrenheit right now. 70 F, 21 C. Both same thing. All right, ladies and gentlemen, let's go ahead and do some intros. Let's go ahead and get started here. All right. I mean, weather is a definitely. I'm sorry, but math must be done. But I promise you, today, ladies and gentlemen, it will be easy. Okay, let's get started today. Welcome back to Tuesday. Hopefully a nice weekend. All right, so for today, ladies and gentlemen, we are going to be covering a brand new chapter. As a friendly reminder here, remember that the chapters 5, 6, and 7 test has been put up, well, since the semester started. All the homework, all that stuff needs to be done by the 28th. Okay, so that is, again, next Thursday. So next Thursday is the due date for all the stuff from chapters 5 to 7. Now, we are getting into the final third of the class here, which will cover chapters 8, 9, 10, and 4. Chapter 4 will be the last chapter that we'll do. But we need to get through chapters 8, 9, and 10 first. We're going to start today with chapter 8, okay? Now, we're just going to do the one section here in chapter 8, as we can go along a little bit slower. It's really not too bad. Some days we'll go a little faster, some days we'll go a little bit slower. It's no big deal. We're on a good pace to get things done. Yeah, everything for chapters 5 to 7, Pistache, is due on the 28th, okay? Everything for chapters 5 to 7 specifically. So you can see on my math lab, you'll see those due dates exactly changed to the 28th respectively, okay? At 11:59 p.m. All right. Now, let's talk about what we did here last time, because that's really the big key here. All right, what we did here last time is we went ahead and did the normal CDF. We did the inverse norm functions. That's what we did here last time, is working with the normal distribution. So effectively, we know now how to use those functions on our calculator. We know exactly how those things work out. Again, we had the lower, the upper, the mean, and the standard deviation. Today in section 8.1, what I'm going to talk about here is I'm going to talk about, yeah, the same exact thing. All right, good job. All right, so we're going to talk about something pretty similar here, just with a different perspective tacked onto it. It's actually pretty cool. All right, we're going to talk about a similar thing that we've kind of acknowledged here, though. Again, with this one slight alteration. That's what we're going to do here in section 8.1. So let's go to the big board here for today. Let's see what we're working with. All right. Okay, so today we're going to be talking about sampling distribution. So now we're getting into the nitty-gritty details about actually taking a sample. Like, let's say we're asking that survey question to a finite amount of people. You know, hey, do you like brand A? And you can say yes or no to that question, or whatever the case may be. And we're now going to be able to take those guys, okay? Take those finite number of people and hopefully extrapolate that to a population, okay? We are slowly kind of moving toward there. Now, for us to understand that, we're going to have to use it, in this case, a sampling distribution. You know, what is, we do a sample, we take the results down, and what does the distribution look like once we compile all the results together? And maybe we need to take some probabilities based on our given results, and you see what we essentially get. So, let's take a look at question 1 here that we can see here on the screen on the left. Alright, so how do we find the mean of a sampling distribution? Okay, so if we want to find the mean of a particular sampling distribution, we make the assumption that the mean of the sampling distribution is equivalent to the population mean. So if we want to make a proper comparison, we say, alright, let's assume that the mean of the sample is going to be pretty equivalent to the mean that we had from before that's given in the population. So if we're given a standard, let's stick with that standard. Okay, that's essentially what it is. Now, the big difference here comes from question number 2. Question number 2 says, how do we find the standard deviation of a sampling distribution? Now, of course, you're no longer using the entirety of the sample. This time, entirety of the population, excuse me. This time you're using an actual smaller sample, again, a subset of the population. So the standard deviation here is equal to the population standard deviation divided by the square root of the sample size. And here we can see the notation. Got this rho x bar, rho sub x bar is equal to the population standard deviation rho divided by the square root of n. Okay, so that's the notation that we have here. Perfect. Okay, so one of the things I would suggest you write down is definitely that second one, because that's going to be the biggest change between what we did last time and what we're doing here today. All right? All right. Now, why are these two things important? Well, because we're going to employ what's called the central limit theorem. Let's talk about that and where this is going to fit into the grand scheme of things. Question number 3. What is the central limit theorem? Basically, it says, regardless of the shape of the underlying population, so no matter what the population looks like, as the sample size n increases, the sampling distribution becomes more and more approximately normal. So the bigger the amount of people, the more amount of people we could choose for a survey. So maybe instead of picking 50 people, you pick 100 people. The more and more that particular sampling distribution is going to look like our ideal distribution, which is the normal distribution, that bell-shaped curve that we've talked about from before. And this is going to be really important. Why is this third question really important? Well, for one simple fact. And that is, well, if it looks more approximately normal, then we can use the same two things we talked about last week, which is normal CDF and inverse norm. Okay? So essentially today is like a lot of repeat about what we talked about from before, with one minor change. That minor change here That minor change here being the standard deviation that we have right here. And that's it. As simple as that. You're probably wondering, how do we go ahead and find out some problems? I said, all right, let's go ahead and work with some problems here, and let's see what we're working with. All right, so I'm going to move this, actually, I'll move this to the left here. All right, so the question that we're going to work with here in this for today is, let's work with number 19. All right, so that's the first example we'll work with. All right, so 19 talks about gestation period. All right. So the length of human pregnancies is approximately normally distributed with a mean of 266 days and a standard deviation of 16 days. So here we're given a mean here. Let's just write these down. Mean of 266 and our standard deviation here of equal to 16. All right, and we're going to answer a few of these questions here. All right, let's go to part C. I'm going to kind of skip around a little bit. All right, so what is the probability that a random sample of 20 pregnancies has a mean gestation period of 260 days or less? So we're taking a sample size here of 20. We're trying to find the probability that a random sample has a mean gestation period of 260 or less. So we take our sample, we say, all right, what's the probability that that's going to be 260 or less? Now, let's talk about how we can set this up here. All right, so recall from last week here about what we talked about back in chapter 7. We did the inverse norm, and we also did the normal CDF. Now, to give you a friendly reminder here, what does normal CDF look like? Remember that we went ahead and we hit the second key and the vars key on your calculator, and we went to this dude, which was normal CDF. Okay? Remember that we do have these 4 numbers here. I keep thinking 5 for no reason, because reasons. Alright. So, we have a lower, we have an upper, we have a mean, and we have the standard deviation here. Now, let's take a look at what we did last time. Last time when we looked at 260 or less, all right, don't forget we used the following. Remember, we used -1, second and the comma key to get the little letter e, so -1 e to the 99. All right, we were talking about 260 or less, so we're talking from, remember that -1 e to the 99 had reflected negative infinity on your calculator. We'll go up to 260 days or less, so we'll go to 260. And then we put our mean. Our mean here is given to us as 266, so that doesn't change, again, just from what we talked about in questions 1 and 2. Now, the thing that does change here, everything else is pretty much the same that we talked about here from last time. Alright, so let me write this down. The thing that definitely changes is the last number, and that is the standard deviation. We're given a specific sample size here, but remember that the standard deviation, according to what we have here on our, let's go back to our handout, is the population standard deviation divided by the sample size. So we're given here, in this problem, we're given the population standard deviation as 16. We're also given a sample size here because we randomly chose 20 pregnancies. So it's like, all right. So here we have the population standard deviation of 16, and we're going to divide that by the square root of the sample size we chose here, which is 20. Okay. And we're going to plug this all into the calculator in for this. So if you have the old school, new school calculator, I think you know. Again, if you have the old school calculator, this is what you want to have show up on your screen. On your old school calculator, look like this: 16 divided by square root of 20. And then just remember to close off both parentheses at the end, like so. But, let's see, this guy. 16 divided by the square root of 20. And we will paste that. Second and the comma key there, Juan. So second key and the comma key. Oops, that's not that. second key, and the comma key. So right here, sorry, let me do that for just a second. So if I'm entering this in, I have -1, second key, and the comma key to get the blocky letter E there, 1. And I can hit 99 after that. We go ahead and enter, paste that in. Go ahead and enter here. And here we get 0.0468. Sure. No problem. I'm here to help. Okay, great. All right. Any questions about that problem so far? We're obviously going to try some more examples, guys. So, but any questions about that so far? Okay. Want to be sure that you guys are replicating this answer on the calculator, because you will need to know that in order to do certain problems. So make sure that you be able to get this answer here. We'll see what you guys get for the next one here. So let's go over the next one. Okay, more examples for sure. Okay. All right. So let's look at letter D. We'll change this up just a little bit. What is the probability that a random sample of 50 pregnancies has a mean? Let's go with 260 days or more. So I'm going to just change this up just a little bit. Say n is equal to 50. What's the probability of 260 or more? So, all right. So, we're going to use normal CDF for this, just like we did the last problem. Can any of you tell me what numbers are we going to use for normal CDF? What numbers should we use for 260 or more, a sample size of 50? Okay. What number should we use for 260 or more with a sample size of 50? I need to put in 4 numbers. What are those 4 numbers here? Anybody tell me what those numbers are? We got a lower, we have an upper, we have a mean, we have a standard deviation. So again, you need to look at those numbers there. There they are. We have lower, upper, mean, and standard deviation. Now you gotta tell me what the numbers I need to plug in have to be in order for me to solve for this particular problem. Let's see. Again, please just put a guess in the chat. That's all I ask. All right. Okay. Yeah, you're right, Jake. Yeah. I just saw that myself. I actually thought you put 50 the first time, but yeah, you're right. Okay, very good. All right, so all of you have the right of it here. Anna, you just forgot the square root at the end, but I think I know what you meant there. So we have 260, that's correct. We're going to do 1e to the 99. Okay, again, that represents our positive infinity. So 260 to 1e to the 99. And then we do have here, specifically, we have 266 for our mean. And 16 divided by the square root of 50, and that is correct. Good. Alright, let's take a check, and let's see. Let's plug this in. And let's see if you guys will get the same answer here. We wanted the upper to be 1e to the 99. So second and comma for e, we'll block e, 1e to the 99. 266, and we want to change this 16 to 16 divided by the square root of 50 for our new sample size here. Alright, so let's see what we get. Alright, so doing that out here, we get 0.9960. Okay. Alright. Okay, please type in got it if you got this on your calculator. Make sure that everybody got this same answer here. Please type got it in the chat if you got this on your calculator. Okay, good, good. Alright, very nice. Got Julian's. Julian's got it. Okay, good. Juan got it. Good. Alright. Everybody on the same page. I'm really happy to see that. Alright. Very good. Very good. Alright. Let's try. Let's go ahead and try another one. Okay. So let's try another one here. Alright, now you may see a question like this next one here on the homework. I want to prep you for this question as well, because again, it could be a potential question on the homework and or test, of course. So we're going to look at the letter F here. Alright, so it says, let's go ahead and read this off here. It says, what is the probability a random sample of size 15 will have a mean gestation period within 10 days of the mean? Okay, so here, let's at least acknowledge one thing right away. First of all, we have a new sample size. So instead of 50, we actually have 15, 1-5, instead of 50. All right. And now we also want to find the probability, as it says here. We want to find this probability that, you know, about within 10 days of the mean, within 10 days of it. So probability of within 10 days of the mean. Okay, well here's a question for you. What does 10 days, what does within 10 days of the mean exactly, you know? But what exactly does that mean here? Within 10 days of the mean here. 10 days or less? That's a good thought. I like that answer, but it's not exactly correct here. Okay, that's correct, Jake. Right. So it's not just less than 10 days, Anna. We could also consider that to be more than 10 days as well. So it is plus or minus those 10 days here, as opposed to just minus 10 days. So within could mean, again, just at least 10 days up or 10 days down. Okay? So, yeah, it could be 10 less or 10 more. That's correct, Clay. All right, so because it could be 10 less or 10 more, or as Jake put, plus or minus 10, you know, yeah, it's just like you got half the answer right, you just forgot the other half, which is perfectly cool. All right, glad we will clear up all those things. Anyway, our mean here is 266, so of course if we plus or minus 10 days, we're looking at between 256 and 276 days, right? So if we add or subtract 10, we get 256 to 276. So in reality, we're looking at the probability between 256 and 276 days. that would reflect within 10 days of the mean. Okay, so how do I set this up here? We're gonna, of course, use normal CDF like we did in the last few problems. That part is definitely true. What numbers are we going to use underneath normal CDF? What numbers to use in the calculator here? Go back to our normal CDF guy. What numbers are we going to use here for this example? What numbers are we going to use here for this example for normal CDF? Again, put your guesses in chat. Alright, 256, 276, 266, 16, and the square root of 15. Okay. That's correct, Clay. Very nice. Yes, good, good. Alright, that's correct there, Big Chimpin. That's right. Excellent, excellent. That's correct, Shioma. Absolutely right. See, we have a slight delay in terms of, have to fix that delay from that thing. So, keep thinking that. I keep forgetting that there's a big delay between that. Alright, anyway. Alright, that's correct. So let's put that in. 256, 276. Alright. And let's put it in 266, of course, in 16 divided by the square root of 15, 1, 5. And so here we get our final result here of 0.9845. All right. Okay, any questions about that? Any questions about that example? Hopefully that wasn't too bad. Alrighty. Good stuff. Alright. Okay, let's take a look at another example here. Okay, so there's a couple more examples I'd like to cover here, just so you can get different looks about how to do some of these problems here. All right, so the next one I wanted to do here is here we go. All right, we'll do this one. All right, so let's look at this one here. The shape of a, let's look at 25, okay? So 25 says, the shape of a distribution of the time required to get an oil change at a 10-minute oil change facility is unknown. However, records indicate that the mean time for an oil change is 11.4 minutes, and the standard deviation for an oil change time is 3.2 minutes. Alright, what is the probability? Let's look at letter B. What is the probability that a random sample of 40 oil changes results in the sample mean time of less than 10 minutes? So B here, so let's at least take stock in what we have here. So we have the mean, give it to us as 11.4. We have the standard deviation of all these oil change facility things is going to be 3.2. Right, and we are given here for this particular one is a random sample of 40 oil changes. So we know that there's going to be 40 oil changes. All right, and we're trying to find the probability of 10 minutes or less. Let's say I'm trying to keep a promise to get the job done in 10 minutes or less. We give it a go. Okay, so what should I use here for this? What should I use for this exactly? Anybody tell me, what do I need to enter into the calculator to solve this problem? What do you guys think? What do you need in order to enter the calculator to solve for this problem? You know, using, go with the first part here. We're using normal CDF. We got to enter in some numbers here, so you guys let me know what numbers I should enter in. Let you take your time, tell me which numbers I need to enter in. Let's go back to the calculator at least, though. Give you a friendly reminder here. Hello, Slash. How are you? What do you guys think? What numbers should we use here? I got a lower, upper, and mean, and a standard deviation. Alright. -1 e to the 99, 10. I'm not sure, but this music goes hard. Is that the answer to the test question you're gonna have there, Juan? You're like, type it in. I'm not sure, but the music is hard. I respect the hustle, though. All right, very good. That's correct. Okay, so we got -1 e to the 99. That's right. We go 10, 11.4, right? And then we look at the last one here, 3.2 divided by the square root of 40. Let's enter that in here. -1 second and comma 99, then 11.4. I mean, once you get a... I guess so. I mean, that's what most people do once math class is over. I ain't gonna lie, Slash. I mean, but, you know, you don't have to do that, you know. I mean, you could physically just rip them out, but that just takes effort, my man. Like, you're using calories and effort to actually rip out the pages. All you could have done, really, by the end of the semester is you could have just walked out the door in high school. You could have just taken the right hand, you put it next to your head, and you just flip the switch here, and do what I did many a times in many classes, and just flush all the information away until you have to use it someday. Somewhere in your subconscious. That's all you gotta do, man. Like, and it would have taken you less effort than flushing it down the toilet. You could have just imagined flushing it all away like we all do. And it would have saved you a lot of time. Alright? Efficiency's number one, Slash. Alright? Let me just point it out there. Alright? See, I know you have 4D in your name, but see, that's a 5-head play right there. Alright, I'm just saying. Alright, let's see what we get here. Alright, as we do that here, we get 0.0028. Okay, so that's going to be our probability here in this case. Alright. Very good, very good. Alright, nice job. Good job, Chioma. Good job, Chimpin. Alright, good stuff. Okay, now we do have, yeah, 6 cents, calorie count. That... Buddy. Slash, we're keyboard warriors. Calorie count is something we don't do, okay? Alright, if you're gonna count anything, and you're going to be more efficient with your time, Slash, and we're going to use mathematics, do card counting at a casino for blackjack, okay? Maybe then you'll make more money than calorie counting. You don't need to worry about that. We're, you know, come on, man. Health is secondary for every keyboard warrior. That's just only natural. Go to McDonald's. What's a calorie count? Like, okay. What's that? Oh my goodness. Alright, let's look at letter C. Suppose the manager agrees to pay each employee a $50 bonus if they meet a certain goal. Alright, fair. On a typical Saturday, the oil change facility will perform 40 oil changes between 10 and 12. Treating this as a random sample, what mean oil change time would there be a 10% chance of being at or below? Okay, what mean oil change time would there have to be in order there to be a 10% chance of being at or below? Alright, so basically in this particular circumstance, this is where we invert things. So essentially, in this instance here, we are maintaining we still have the same sample size as 40 here from the previous problem. We also maintain the fact that we have the same mean as before, so 11.4 minutes for this thing here. Now, of course, want to motivate the employees by using a particular metric. So, in this instance, alright, again, we're going to use inverse norm here in this instance. Now, we did this last week here, but remember with inverse norm, right, it's just going backwards. We're taking a percentile and then working our way backwards to see exactly how we can maintain that, that thing. So, let's go ahead and hit second bars. Remember that inverse norm here has 3 numbers that we're going to enter. If you have the old school calculator here, you're going to make that. You don't need to make too many adjustments for this particular problem, but you want to keep it at left. For old school calculators, this is automatically at left. Now, the one thing to keep in mind in regards to this problem is we want a 10% chance or below. That way he doesn't have to pay out because he's like me, a cheap ass. All right, so thing is, let's see if he wants a 10% chance of that being at or below. All right, we're gonna have a 0.10 for our 10th percentile because that's essentially what we're asking for here. We're looking at the 10th percentile. All right. Alright, so that time or below will represent essentially the minimum that we can do to have this work out the way we want it to. Alright, so here we have 11.4, but since we have 40 oil changes in the next 2 hours, we're going to go ahead and do the same thing we did in the last problem. We're going to do 3.2 divided by the square root of 40. Again, we do adjust the standard deviation here because we are looking at a particular sample size. So let's go ahead and met this out. Let's see what we get. We got 11.4, and we got 3.2 divided by the square root of 40. And we'll do it at the left. For old school calculator users, you don't have to worry about that. It's already set to go. Hit enter. So in order for us to maintain our current, to get that $50, it has to be 10.7516 minutes or below. Okay? And that will be our final answer for part C. So if we deal with the percentile, notice we don't do anything different outside of change the standard deviation to reflect the sample size that we're working over. All right, any questions about that? Man. Pretty easy, hopefully. Not too bad. Oh, why did I write or? That's based on the context of the question there, Chioma. Because it did ask us here in this one. All right, he wants to give $50, right? So it's like saying, okay, I give you a challenge. The goal established by the manager is keep your times at 10.7516 minutes or below, and I'll give you the $50. So I just wrote or below, since that's in the context of the problem there. Minutes. This is MIN for minutes. I'll say minutes. There you go. Sorry for the handwriting. Apologies. Hopefully that's a little bit easier to read. Any more questions, Chioma? Or is that okay? Okay. Alright. Okay. Good. Alright. So, that in a nutshell, ladies and gentlemen, is section 8.1. Alright. It's up to you guys if you want me to do another example. I can do another example. Otherwise, if you're good with these examples, then this is pretty much the entirety of 8.1 and the types of problems you're going to see on the homework anyway. Same exact things. So, any questions, guys? You guys want me to do another example, or are you guys good? Let's put a poll. Why not? Oh, like one more? Okay, I can do one more. It's not a big deal. All right, so I'll do one more really fast. It's fine. Okay, so we could do 26 here. Fine. So Time spent in a drive-thru. The quality control manager of a Long John Silver's restaurant wants to analyze the length of time that a car spends at the drive-thru window waiting for an order. Remember that the mean time spent at the window is 59.3 seconds, with the standard deviation of 13.1 seconds. All right, the distribution of the time is skewed right, database on substitute. All right, that's fine. All right, so put the mean here at 59.3, and the standard deviation of 13.1. Now, it doesn't matter if it's skewed right or not. The overlying population does not matter in this case, because you can based on the theorem, you can assume that it'll be approximately normal the more orders that we have to use in our sample. All right, so let's look at letter B. That'll be important here. Letter B says the quality control manager wishes to use a new delivery system designed to get cars through the drive-thru faster. Random sample of 40 cars is used. All right, and the sample mean time here is spent at the window is 56.8 seconds. What is the probability of obtaining a sample mean of 56.8 or less, assuming that the population mean is 59.3? Okay, which is what we're already given here. All right, so here we are trying to find the probability with n here being 40. We're trying to find the probability here of 56.8. Okay, or less. So here in this instance, we're just going to go ahead and use our same normal CDF. Since we're looking at 56 or less, we'll do minus 1e to the 99. We'll use 56.8. I mean, technically you could use 0, but it'd be the same thing. We have a mean here of 59.3. And a standard deviation here of 13.1. But since we're given a sample size, we're going to divide that by the square root of 40. And we'll enter that into the calculator as such. Okay. Go to the calculator here. So hit second in vars. Go to normal CDF. Minus 1e to the 99. 56.8. 59.3. And 13.1 divided by the square root of 40. Let's see what we get. All right, so here we get 0.1137. That's the probability that we get here. So the question is, do you think that the new system is effective? Well, if we look at the context of this problem here, 11.37% of the time, underneath our current conditions, we would have sample mean of 56.8 seconds or less. So the answer is yes, that's pretty effective. All right, it's not unusual, but it is effective. All right, since that's the question there. All right. You want to get people out the door as quickly as possible. So these things are actually pretty important for business, in all honesty. Okay, let's look at letter C. Letter C says, treat the next 50 cars that arrive as a simple random sample. There is a 15% chance the mean time will be at or below blank. Okay, so in this particular instance, we're going to now simply use, since we're looking for the 15th percentile here, we're going to use inverse norm here for this particular problem. The area we'll use here is the 15th percentile, so 0.15. We'll use the same mean as before here, which is 59.3. So those two parts, not too bad. Now, the only thing that does change here is we have the standard deviation of 13.1, so that's fine. But in this case, the sample size changed. In this case here, we're looking over the next 50 cars, not the next 40 cars. So So we want to put the square root of 50 here in this instance, since n is equal to 50. And then we'll go ahead and see exactly what that's going to be, plugging that into La Calculadora. Okay, so second in bars. First norm. $59.3. 13.1 divided by the square root of 50. Close that off. Left. Paste. See what we get here. So here we get 57.3799. Alright, so it'll be 57.3799 seconds or below. So there's a 15% chance the mean time will be at 57.3799 seconds. And that will be your final answer for that problem. So as you can see here, you're given you're given a sample size, and again, you're asking what's the probability. Remember to use normal CDF, using a percentile. Go back to our regular go standby here of inverse norm. All right, cool. Any other questions that you guys have? Any more questions, guys? If you have any more questions, again, type no in the chat if you have no questions. That way I know to move forward or do what I need to do, I guess. Push me. Okay. Nope. Okay. All right. Well, if there are no more questions here, we will end off here for today. That is all I needed to do here for today in order to keep pace with where we're at. Okay. So, yeah, we get to end off here a bit early here today, but we got, that's all you really need to do for 8.1. There's only just one major change between what we did at the end of Chapter 7 and what we're doing here for this section. There's really not a whole lot of difference at the end of the day. So, there you go. Pretty simple, pretty straightforward. All right. That'll take care of it for today, everybody. I want to thank everybody for coming out here to the stream once again. And we're going to come back here on Thursday. Same time, same place, everybody. We're not going to change. We're keep on moving. We're at a very good pace, ladies and gentlemen. I know we have 4 chapters to go, but really, we have lots of classes to go to get that stuff done, and we should be able to finish it with plenty of time available. So, again, continue to working on your homework and test here for chapters 5 to 7. And if you haven't done so already, please go ahead and get started on that. And, yeah, we will see you all on Thursday. Everybody, have yourself a wonderful and a beautiful afternoon/evening. All right, I hope you have a chance to take care and relax a little bit. And we'll see you in a couple days, all right? You guys know where to contact me. Please feel free to contact me on email or Discord. I'll be right here waiting for you. All right. Have a great one, everyone. Have a great day. And we will see you all later. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right? Take care, everyone. And we'll see you in a couple days. See you later, everybody. All right. Bye. Bye, everybody.